Alright guys, we're going to do a couple of the problems that came from that worksheet of graphing polynomials. I believe this was numbers 4 and 5, but they didn't actually have numbers on them, so you'll recognize this from the first page at the bottom. If I'm starting with this function and I want to find where it equals 0, I would like to get rid of those fractions. So let's start off by multiplying both sides by 5. I'm allowed to do that as long as I do it to both sides, and I multiply it all the way through. So I'm going to distribute all three things. So I'm going to have x to the 5th minus 10x cubed plus 9x equals 0. The other thing that I notice is they all have an x in common. So I'm going to take an x out, and I'm left with this, which is a much more normal trinomial, more normal looking trinomial. Leave that x on the outside. Now I know that has x to the 4th, but this still is kind of in the form of a normal trinomial. I still can have two things that multiply to give me x to the 4th, and that would be x squared and x squared. And notice, because there's an x squared in the middle, an x squared term in the middle, that when the things add together it will work out. So I need two things that multiply to 9 but add to negative 10, and that would be negative 1 and negative 9. And I'm probably going to erase this, but just notice x squared times x squared is x to the 4th. Negative 1 times negative 9 is positive 9. This is negative x squared if I multiply those two. This is negative 9x squared. And if I add those together, that's negative 10x squared. So I have factored it correctly. And actually, this can keep on factoring. This is a big one. Notice that that's a difference of two squares. I can factor that as x minus 1x plus 1. And I can factor the x squared minus 9 is x minus 3x plus 3. And if I set each of those factors equal to 0, I will find the zeros. So if I set x equal to 0, I'm going to get x equals 0. If I set x minus 1 equal to 0, I'll get 1. X plus 1 equals 0 will give me negative 1. X minus 3 equals 0 will give me 3. X plus 3 equals 0 will give me negative 3. So this function actually has 5 zeros. Some other things that I need to look at are the end behavior. So if I look back at the very beginning, notice that this is a 5th degree function. I'm circling it up at the top. That's a 5th degree function, and it's also positive in the front. So that tells me it has odd end behavior. So the ends are going to kind of look like that. All right. So if I just wanted a general shape, notice that all of those zeros only happen once. There's no squareds on them or cubes on them or anything like that. They all happen once, so that means that the function is going to go straight through them. I'm going to go ahead and graph my x-intercepts. So I had 0, negative 1, positive 1, negative 3, positive 3. That is a lot of zeros. And honestly, you could plug in some numbers if you wanted to see how high up and how low it goes. But I think I probably would just do the end behaviors and then the going straight through or not going straight through. So I know the ends are doing that. They're going up and they're going opposite. And it's going to go straight through all the zeros. So straight through there, straight through there, straight through there, straight through there. And I don't really know how much it goes up and down unless I plug a test point in. But that's the general idea. Okay, the next one was on the back side, and it looked like this. 3x to the 4th plus 3x squared minus 6. We're supposed to graph that. So the first thing I'm going to do is find the zeros. So I set it equal to 0. When I look at this, the first thing I notice is that all of those can be have a 3 factored out. They have a GCF of 3. So if I divide 3 out, I end up with 3 on the outside of x to the 4th plus x squared minus 2 equals 0. Technically, I could divide both sides by 3, so that 3 doesn't really matter a whole lot now. It doesn't have an x with it, it's just by itself, so it kind of could be divided out. Now this actually is a lot like the last problem. I have an x to the 4th again, but this is still a trinomial, so now we know that I can split x to the 4th up into x squared and x squared. And then I need two numbers that multiply to -2 but add to 1. So I'm going to say plus 2 and minus 1. That can, the x squared plus 2 can't factor anymore because it's only 2 terms and it's not the difference of 2 squares or something like that. But x squared minus 1 can factor into x plus 1, x minus 1. So this one's kind of interesting because it has real zeros and non-zeros. If I set each factor equal to 0, it's going to look like this. And the x minus 1 and the x plus 1 just end up with real zeros, -1 and +1. But this one, if I try to solve it, I would subtract 2 to the other side, and then I would take a square root, and I would get x equals I on the square root of 2. Actually, plus or minus I on the square root of 2. So it has 2 non-real roots. That is not going to show up at all in my function. So what will show up is the real zeros. So if I have my graph, there are some easy things I can do. Obviously the zeros, which is -1 and +1. Just make those big. And then if I plug 0 into the original function, I can get the y-intercept, and I notice that it's -6. And I think, okay, that wasn't very curved, but this function is supposed to be like a parabola that kind of looks like that. So even though it's a 4th degree function, it's actually a parabola because the, it looks like a parabola because the imaginary zeros don't really show up.